Hello. Today, we will take a journey together. We travel not across land or sea, but through space. Our destination is a small planet, the closest one to our sun. Its name is Mercury. When you first think of Mercury, what comes to mind? Maybe you picture a small, rocky ball, a world covered in craters, like our moon, a place incredibly hot because it is so near the burning sun. These ideas are true, but they are not the whole story. Mercury is much more interesting than it first appears. It holds deep secrets. It presents puzzles that scientists are still trying to solve. Let's explore these mysteries. This is not just about learning facts. It is about thinking like a scientist. It is about asking questions. It is about looking at the evidence and wondering, what does this really mean? Let us expand our view of this small, fascinating world. First, let's look at some basic facts. Mercury is the smallest planet in our solar system. It is tiny compared to Earth. Imagine Earth is the size of a large ball. Mercury would be like a small marble next to it. Mercury moves very fast around the sun. Its year, the time it takes to go around the sun, once, is only 88 Earth days. That is very quick. But Mercury spins very slowly on its axis. One full day and night cycle on Mercury takes 176 Earth days. Think about that. One day on Mercury is longer than 2 of its years. And yes, Mercury is a world of extreme temperatures. During its long day, the surface temperature can reach over 430 degrees Celsius, about 800 degrees Fahrenheit. That is hot enough to melt lead. But during its equally long night, the temperature drops sharply. It can fall to minus 180 degrees Celsius, about minus 290 degrees Fahrenheit. This huge temperature difference is one of the most extreme in the solar system. These facts are interesting, but they also set the stage for Mercury's biggest puzzles. Imagine you could slice Mercury in half. What would you see? You would find something very surprising. Deep inside, Mercury has a heart made of metal, mostly iron. This is called the core. All rocky planets, including Earth, have a metal core, but Mercury's core is different. It is enormous. Scientists estimate that Mercury's core makes up about 70% of the planet's total mass. Think about that number, 70%. For comparison, Earth's core makes up only about 30% of its mass. Why does this tiny planet have such a gigantic metal heart? This is a major question. It challenges our understanding of how planets form. Usually, we expect a balance between the rocky outer layers and the metal core. Mercury breaks this rule. How did it get this way? Scientists don't have one single answer yet. Instead, they have different ideas, called hypotheses. They use computer models and evidence from space missions to test these ideas. This is critical thinking in action. Let's look at some of the main hypotheses. Idea 1. The big hit old version. Perhaps, long ago, when the solar system was young and chaotic, Mercury was larger. Then, a smaller space object, maybe the size of a large asteroid, crashed into it. This giant impact could have blasted away much of Mercury's outer rocky layers, leaving behind the dense, metal core. This is similar to how some scientists think our moon was formed after a large object hit the early Earth. Idea 2. The bigger hit, new version. More recent studies suggest something even more dramatic. What if two large objects, maybe similar in size, collided? But instead of a direct hit, it was more of a glancing blow at very high speed. Computer simulations, like those led by Pic Franco and his team in Brazil, show this could happen. Such a crash could strip away even more of the lighter, rocky material from both objects. What remained could have merged to form the Mercury we see today, mostly core with a thin outer shell. This idea forces us to think differently about the early solar system. It might have been a place of truly massive collisions. Idea 3. Baked by the sun. Another idea relates to Mercury's location. It formed very close to the young, incredibly hot sun. Temperatures might have reached thousands of degrees Celsius. Perhaps this extreme heat simply vaporized or boiled away much of the original rock on Mercury's surface, leaving the heavier metal core behind. Idea 4. The solar wind's push. The early sun also produced a strong wind of particles. This solar wind, moving through the dust and gas cloud where planets were forming, could have pushed lighter particles away more easily than heavier metal particles. Maybe Mercury simply had trouble collecting the lighter, rocky stuff, because the solar wind blew it away. Which idea is correct? We don't know for sure. Scientists need more evidence. Each hypothesis represents a different way of thinking about the same puzzle, based on the clues we have. Ice in the solar oven. Here is another strange fact about Mercury. Despite the scorching daytime heat, scientists have found evidence of water ice. Where? In deep craters near Mercury's north and south poles. These craters have areas that are always in shadow. The sun's rays never reach the bottom. In these permanently dark, cold spots, temperatures remain incredibly low, far below freezing. This discovery, confirmed by the Messenger spacecraft, was a surprise. How can ice exist on the planet closest to the Sun? The permanent shadows explain how it can stay frozen. But it doesn't explain where the water came from in the first place. Did comets or asteroids carrying ice crash into Mercury, delivering water to these cold traps? Or did water vapor escape from inside the planet through volcanic activity long ago and then freeze in these dark craters? This is another open question that requires more investigation. Humans have only sent a few robotic explorers to Mercury. It is a difficult place to visit. The Sun's intense heat requires special protection for spacecraft, and the Sun's strong gravity makes it hard to slow down a spacecraft enough to enter orbit around Mercury. The first visitor was NASA's Mariner 10. It flew past Mercury 3 times between 1974 and 1975. It gave us our first close-up pictures and discovered Mercury's weak magnetic field. Then, there was a long gap. Decades later, NASA's Messenger spacecraft arrived. It became the first mission to actually orbit Mercury. From 2011 to 2015, Messenger mapped almost the entire surface, confirmed the water ice, and gathered much more data about the planet's composition and its huge core. Now, a new mission is on its way. It is called BepiColombo. This is a joint project between the European Space Agency, ESA, and the Japan Aerospace Exploration Agency, JAXA. Launched in October 2018, BepiColombo is taking a long, looping path through the inner solar system. It uses flybys of Earth, Venus, and Mercury itself to gradually slow down. It is expected to finally arrive in orbit around Mercury in December 2025. BepiColombo carries 2 orbiters with advanced instruments. They will study Mercury in greater detail than ever before. Scientists hope BepiColombo will provide crucial evidence to help test the different ideas about how Mercury formed its giant core. It will measure the magnetic field precisely, analyze the surface materials, and peer into the planet's interior. Keep asking questions. Mercury reminds us that even the worlds closest to us can hold big surprises. Its giant core and polar ice challenge our simple ideas. They force us to think more deeply about how planets form and change over billions of years. The story of Mercury is a story of scientific mystery. It shows how we learn, we observe, we wonder, we propose ideas, and we send missions to gather more clues. As BepiColombo begins its work in late 2025, we stand ready to learn more. But perhaps the most important lesson from Mercury is to keep asking questions, to think critically, and to always be open to new perspectives about our universe.